Assalamualaikum and hello to everyone. In this video lesson, we will continue for part 1 of chapter 3. In this video lesson, we will continue with the third subtopic, and like in previous video, the objective for this subtopic is on the right of the screen. Now, let's look at the second steady flow device called compressors. And what we see here can also be used for pumps. Because why? Because both of them are work input devices, meaning that in terms of work interaction, work in is present and work out can be neglected. Other possible conditions are compressors can also be adiabatic, and depending on the question, kinetic energy and or potential energy can sometimes be neglected. The figure given is the schematic diagram for a compressor. Now, let's look at an example on how to use the steady flow energy equation for a compressor. For this example, we will consider an adiabatic compressor. Remember to write the conditions from the question before applying the SFEE. Start with writing the general equation for SFEE, then cancel the terms based on the conditions given. Rewrite the remaining equation, and to determine work input, we can rearrange the equation as follows. Now, if kinetic and potential energies can be neglected, then the equation can be reduced to as follows. As you can see in the SFEE, there is the term for specific enthalpy H. For values of specific enthalpy, it will depend on the type of substance, and for water, refrigerant R134A, the values for specific enthalpy is read using the property table. For gases, the term for specific enthalpy is replaced with its relationship specific heat, CPT. Now, let's look at the first example for compressors. You can pause to read and understand the question properly. For step 1, please try to draw the schematic diagram, and we can label the inlet as state 1 and exit as state 2. For step 2, write the required equation, and from this question, since the volume flow rate is already given, we can use the relationship between mass and volume flow rate to solve for the first item. For net work input, we will use the SFEE, and please remember to write the conditions given in the question. From the general equation, cancel the terms based on the conditions, and then rearrange the equation to determine the work input. For step 3, determine the required properties for each of the state based on the substance. Since the substance is R134A, we will use the property table to determine the required properties. Please remember to determine the phase for each state before reading the properties. As you can see, for state 1, the phase of the substance is in the superheated region. Therefore, please use the appropriate tables to read for the properties, specific volume and specific enthalpy. For state 2, as you can see, the phase of the substance is still in the superheated region. Therefore, using table A13, we can read for the value for specific enthalpy at state 2. For step 4, substitute the required values and solve for the equation. So for mass flow rate, the answer given is 0.115 kg per second. And for work input, the answer is 6.7952 kilowatts. Now, for the second example for compressors, you can pause to read and understand the question properly. Again, for step 1, please try to draw the schematic diagram and label the inlet as state 1 and exit as state 2. For this question, we can see that the amount of work input is already given. Therefore, we have to label the value, and also don't forget to label the amount of heat loss in unit kilojoules per kg. For step 2 now, to determine the mass flow rate, we will use the mass flow rate equation with the relationship to volume flow rate, because from the question we can see that the volume flow rate has already been given. To determine the exit temperature, since the substance is a gas, we can solve for T2 using the SFEE. Remember to write the conditions given in the question. Start with writing the general equation, then cancel the terms based on the conditions, and rearrange the equation in the form of work input. Now, since the substance is a gas, H must be replaced with CPT in the equation. For step 3, using the related ideal gas equations, determine the required properties at state 1 and also state 2. And for step 4, substitute the required values and solve for the question. If there are any questions regarding the examples for compressors, please do not hesitate to ask me. Now let's look at the third steady flow device called nozzles. Nozzles are used to increase the velocity of fluid by decreasing its pressure. There are no work interactions here, therefore work in and work out can be considered neglected. Other possible conditions are nozzles can also be adiabatic, and depending on the question, potential energy can often be neglected. The figure given is the schematic diagram for a nozzle. Okay, now let's look at an example on how to use the SFEE for a nozzle. For this example, we will consider an adiabatic nozzle, and potential energy can also be neglected. Start with writing the general SFEE and then cancel the terms based on the conditions. Rewrite the remaining equation, and as you can see, the mass flow rate is the same, therefore we can cancel the terms for mass flow rate. And to determine the exit velocity, we can rearrange the equation as follows. Remember, this is only an example on how to use the SFEE for a nozzle. Now, as you can see in the SFEE, there is the term for specific enthalpy H. Similar like other devices, the values for specific enthalpy is based on the type of substance. So for water and R134A, the values for specific enthalpy is read from the property table. And for gases, the term for specific enthalpy is replaced with its related specific heat CPT. Okay, now let's look at the first example for nozzles. Please try to draw the schematic diagram given in step 1, and please do not forget to label for state 1 and state 2. For this question, there is an amount of heat loss from the nozzle, so we can also label Q out here in units kilojoules per second. For step 2, to solve for mass flow rate, we will use the mass flow rate equation. To solve for exit velocity, we will apply the SFEE and remember to list down the condition given in the question. Start with writing the general equation and then only cancel the terms based on the conditions given. Rearrange the equation to find for exit velocity. Now for the third item, for exit area, since the mass flow rate is the same, we will also use the mass flow rate equation, but this time at state 2. Okay, for step 3, since the substance is steam, which is a byproduct of water, we will use the property table to determine the required properties. Again, I would like to emphasize that please determine the phase of the substance at each of the state before reading the properties. So for state 1, we can see that the phase of the substance is in the superheated region. Therefore, using table A6 at 4.5 megapascal, 600 degrees Celsius, we can read for the values for specific volume and specific enthalpy. For state 2, when we check the phase of the substance, we can see that it is still in the superheated region. Therefore, using table A6 at 1.8 megapascal, 400 degrees Celsius, we can read for specific volume and specific enthalpy at state 2. For step 4, substitute the required values and solve for the question. For mass flow rate, the answer is 5.476 kilograms per second. And for exit velocity, using the SFEE, we can see that exit velocity here equals to 899.15 meter per second. And for exit area, using the mass flow rate equation, we can see that the exit area here is 0.001026 meters square. For the second example for nozzles, feel free to pause to read and understand the question. For step 1, please try to draw the schematic diagram and labels for state 1 and state 2. For step 2, since the mass flow rate is already given, we will use the mass flow rate equation to find for the inlet velocity. For exit temperature, since the exit velocity V2 is already given, we still have to apply the SFEE, but first please identify and write the conditions for the system. From the general equation, cancel the terms based on the condition. And since mass flow rate is the same, we can cancel for mass flow rate terms. Now, since the substance is a gas, we must replace H with CPT, and using this equation now, we can find for the exit temperature at state 2. For step 3, determine the required properties. Since the substance is a gas, remember to use the correct gas law equations for state 1 and state 2. For step 4, substitute and solve for the question. For inlet velocity, and the second item is for exit temperature T2, and remember to convert the temperature into Celsius as it is mentioned in the question. Now we have come to the end of this video lesson. We will continue with the remaining steady flow devices in the next video lesson. For additional questions, please refer to past examination papers related to the topic. Please leave a comment in the forum section if there are any questions. Thank you and have a good day.